Recently, we saw that frequently occurring patches in natural images can be parameterized by points on a two-dimensional surface called the Klein bottle. What we've been able to do is to improve the performance of convolutional neural nets, both in speed of learning and generalization based on this parameterization. Today I want to talk about the corresponding surface for video. Video is a much harder problem for AI and ML, and so we want to get any leg up that we can. It turns out that the surface that we find can give us the same kind of improvements for video that we were able to achieve for static images. What is a video? It's a sequence of static images. There are often many regions in the image that stay exactly the same as time moves forward. Patches in such regions can be parameterized by the Klein bottle just as static image patches can. What we want to do is guess what might happen in those regions where the patch is actually changing, where there's some motion, rotation, or translation that is occurring. Suppose we have an edge between a dark and a light region, and suppose that we have a point on the edge, maybe in the center of that region, and then we rotate the patch around that point. This small rotation corresponds to a short, straight line path in the Klein bottle. It turns out that there's a construction that can be applied to any surface whatsoever called the unit tangent bundle construction. Each point of the unit tangent bundle corresponds to a pair where the first entry is a point on the surface and the second one is a tangent direction to the surface at that point. Since the construction applies to any surface, we can apply it to the Klein bottle. A very short path in the Klein bottle corresponds to a very short video patch, starting with the original patch and moving in the direction specified by the tangent vector in the tangent bundle. So our guess, and it's an educated guess now, about what the space corresponding to the Klein bottle but for video should be, is that it should be the unit tangent bundle to the Klein bottle. Each of the four red arrows that you see correspond to points on the unit tangent bundle. You can see each of them has a base point, which is a point on the Klein bottle, and then the arrow indicates a particular tangent direction within that Klein bottle. The tangent bundle to the Klein bottle turns out to be rather easy to describe. It's a three-dimensional surface, and it has some simple coordinates that can be attached to it, which are very useful in the same way as the coordinates for the Klein bottle were. It's interesting to move around the Klein bottle and see what video patches the motion corresponds to. We built neural networks with this information built in and got performance improvements very much like the ones that we got for static images with the Klein bottle. Next time, we'll talk about how we managed to improve the performance of neural nets using these ideas.